Hey guys, Brittany here, filming from beautiful Christchurch City Central on my daily quarantine walk. Today I thought I'd talk about color, and what better place to do it than in front of these beautifully spray painted spray cans. Here I have a flower that to me looks yellow, but is it actually yellow? See, the strange thing about color is this flower is absorbing every color of light except for yellow, which is why the light that reflects off it appears yellow to me, because it's not being absorbed. Pretty weird, right? So we're going to talk a little bit about color today and hopefully learn some of the science behind it. If you've ever painted before, you'll know that the three primary colors are red, blue, and yellow, and with them you can create purple, green, and orange. The three primary colors for light are actually different. They're red, blue, and green, resulting in magenta, cyan, and yellow. To understand why for light, red, blue, and green are the three primary colors, we have to understand a little bit about how our eyes actually process light, and this happens in the retina. The retina is a section at the back of your eye that receives this focused light from your lens and converts it to neural signals. So it takes what you're seeing and in your brain converts it to an image. It does this using photoreceptor cells. So there are two different main kinds of photoreceptor cells. One is rods, which allow people to see at nighttime. So usually at nighttime you can't see color very well, but you can still see, and that's because of your rod cells. The cells that allow us to see color and light are called cones. They come in blue, green, and red, and that is why those are the three primary colors of light. This is the visible spectrum of light that humans can see. Humans can see from about 400 nanometers, a violet color, to 800 nanometers, a red color. But there are also things outside of the visible spectrum, such as ultraviolet light, which is even lower than 400, and infrared light, which is over 800. So humans can't see either of these. What we can see is made possible because of our cones. The blue cone peaks at the blue part of the spectra and is also known as a small cone. The green cone peaks at the green part of the spectra, also known as the medium cone. And the red cone peaks right before the red part of the spectra and is also known as the large cone. So we know what we humans can see with just green, red, and blue cones. But what about other animals? Are they actually as bad as it shows in the movies, with cats only being able to see in black and white? So do we think cats can see like this? Or are they able to see more than we thought? What about other animals? Are they better or worse at seeing color than humans are? Let's take a look. First, we'll look at mammals because we've been talking about them the most. Mammals actually have pretty bad color vision because a lot of them are nocturnal. They have about 1 to 3 rods, and primates like us have 2 to 3, usually red, green, and blue. Cats and dogs, however, only have 2 cones, and they can see in yellow and blue, not black and white. A lot of animals actually have much better color vision than us, such as insects. For example, bees have 3 cones as well, but they can see UV light. And butterflies, some of them, like the Japanese swallowtail, have 8 cones where they can see UV, violet, blue, green, red, and broad spectrum. Birds can also see UV light and often have 4 cones. This ability to see UV light can help them recognize feather patterns that humans might not be able to see, similar to the way that bees and butterflies might be able to see patterns on flowers that are invisible to the human eye. Bees and birds might not be able to see red as well as we can. Reptiles, however, can see in a different way. Geckos that are nocturnal are sometimes able to see color at nighttime when we would just be seeing black and white. And snakes are able to combine infrared signals from pit organs with their visual signals to give them this almost ability to see infrared light. Fish also have over 3 cones in their eyes, especially tropical fish, which can often see UV. But perhaps the most impressive animal is the mantis shrimp, which can have up to 16 cones, it's thought. And they're able to change the way that their color vision functions based on where they live. So ones living in deeper water will see the world completely differently from the same species living in shallow water. Pretty crazy. So it turns out, despite us humans thinking that we have great color vision, we're actually pretty bad compared to the rest of the animal kingdom. And while most humans have 3 cones and can see a rainbow worth of colors, not all humans have this luxury. Some humans are colorblind and can only see 2 or even 1 color. There are a few different types of colorblindness in humans that involve 1 or more of the cones not functioning. If 2 cones aren't working, then you are only able to see 1 color. But if only 1 cone isn't working, you end up with these disorders. So if it's your blue cone that isn't working, you end up with tritanopia, where you see the world in pinks and greens, kind of. If it's your red cone that isn't working, or your green cone that isn't working, you end up seeing the world in blues and yellows. And this is because you need both your green and your red cone to be able to differentiate between red and green. Otherwise, everything just looks yellow. Cats and dogs also see the world in blue and yellow, like we were talking about before. But we don't think that they would be able to see it with as much color as we can because they don't have as many cones. This type of color blindness is more common in men because of where the genes are located. The genes for the green cone and the red cone are both located on the X chromosome, which males only have 1 of, while females have 2. Therefore, if their 1 copy is broken, they can't see incorrectly, but females have a backup copy of those cones. I thought the next thing we could do is maybe look online what it's like to be colorblind and do a bit of a colorblind test. So this first site here allows you to see what the world would look like or what a web page would look like when you're colorblind. So I've just taken some Google images of dogs and put it up here so we can see the difference. So this is when you have a blue cone that's not functional. You can kind of see it looks more green and red. So this is what it would look like if we were looking at pictures of dogs and you were red-green colorblind. Still pretty cute. So I've just pulled up this IQ test to check it out and see how I do at identifying colors. So I'm just going to go quickly and click along at this. I can tell that this is a 2, this is an 8, 7, 0, 8. Some of these would be a lot more difficult for you, or you might not be able to identify them at all if you're colorblind. So if you weren't able to see some of those numbers, it might be because you're colorblind, but probably check with your doctor first. I hope you enjoyed the video and learned a little something. Maybe it even took you down a peg on thinking that humans have superior color vision when, compared to a lot of animals, we don't. Thanks for watching and see y'all next video. Can't really see what color things are very well in the dark. Just filming me looking at dogs now. Oh. Why does it look yellow? Is it actually yellow? Do I see this yellow the same way that you see this yellow? How do I know that this is yellow, appears yellow to me, if this yellow is actually yellow? and why it looks yellow. Man, it takes a bit of practice to do this.